This lesson is on section 12.1. It's an introduction to the basics of some of the segments and lines that go with circles. The first one that we're going to talk about is the tangent line. By definition, a tangent line is a line that intersects a circle in exactly one point. So it comes across the side of a circle just at the exact moment it hits one point and no more. Some things that we know about our circles if we have tangents or if tangents are involved. A tangent is a line to a circle. So in other words, this blue line would be a tangent to a circle if and only if, so that means it has to be true, if the line that goes perpendicular from the radius or from the center is a radius, okay? So what that means is if you draw the radius out from the center of the circle and you draw the line that goes and hits right at that point of tangency, that has to be a tangent line. If it creates a 90-degree angle, then it has to be a tangent line, okay? What that does for us is it creates right triangles with the radius, part of the tangent line, and then the radius plus some more. That's going to help us find missing values. So again, the line is tangent to the circle if and only if the line is perpendicular to the radius that's drawn at the point of tangency. So if you draw the radius and it makes a 90-degree angle, then that has to be a tangent line. The second thing that we're going to talk about is inscribed versus circumscribed. We have talked about that in previous lessons, but it comes up again in this section. So something that you have to understand is that inscribed in means it's inside. We would say that the circle is inscribed in the triangle because it's inside and it only touches the sides of the circle at one point, which means that these are tangent lines, and that's why it's in this section. Because you inscribe a circle in this triangle, the sides of the triangle act like tangent lines to the circle. We would also, if we were describing the triangle, say the triangle is circumscribed about the circle. It's around the circle. So circumscribed means it goes around the circle. And again, those are acting as tangent lines. Okay. One of the side notes that goes with that is right here. And it says that the tangent segments, okay, so that means from a vertex to the point of tangency. From a vertex to the point of tangency, that length is going to be the same as that length. So if you start at a vertex of the triangle and you go to the point of tangency on both sides of the circle, those lengths are going to be equal to each other. Okay? Same thing here. When I draw this tangent line and this tangent line, the distance here has to be the same as the distance here. Those are the two major things that we're going to talk about in terms of what do tangent lines do for us in terms of circles. So let's look at some example problems. If I tell you that circle C is inscribed, so it means it's inside the quadrilateral, which means it touches right at one point and creates tangent lines, and it asks us to find the perimeter of the quadrilateral. They give us some values. We know that from x to the point of tangency is 8. So we know from our second theorem on the other page that the distance from x to this point of tangency would have to be 8. We would know that we are given that from y to the point of tangency is 11, so that means from y to this point of tangency is 11. Same thing here, z to this point is 7, z to this point has to be 7. From w to this point is 6, from w to this point also has to be 6. So when you go through and try and find the perimeter, you would add 11 and 7 and 7 and 6 and 6 and 8 and 8 and 11. So that would give us a total of those 22, 14, 12, and 16, And that would give us 30, 52, 62, 64 would be our perimeter. And it's in feet, it looks like, so we would say the perimeter around that would be 64 feet. Okay. That's how we would use that theorem. Remember that one of the other theorem that we learned is that when you draw the radius and if it makes a 90-degree angle, that creates a tangent line. So the distance from here to here is x. Now, based on what we learned back in chapter 10, what does the length from here to here have to be? Well, it's a radius, and so it would have to be the same length as here, so it would have to be x. If I want you to find the value of the radius, what relationship can we set up here, knowing that this is a 90-degree angle? Well, we would use the Pythagorean theorem. We would say x squared plus 10 squared equals, and then we would represent this side by 5 plus x. And so we would square that. So we would do x squared plus 100. Goodness sakes. Now, when we square this, that means that you're going to take 5 plus x times 5 plus x. We would use the FOIL method to stretch that out, so we would do 25 plus 5x, and plus 5x gives us plus 10x. And then our last one would be plus x squared. Now the beauty of this kind of problem is you end up with an x squared on each side of the equal sign. So you can cross them out. And when you put your like terms together, you could minus 25, you would be left with 75 equals 10x, and it becomes a very easy algebra problem to solve. We divide by 10, and x, or the length of our radius, would have to be 7.5. The next kind of problem is a lot like this, but we're going to have to use our logic skills first. Okay, it says a belt fits tightly around these two pulleys. And they want us to find the distance between the centers of the pulleys. In other words, they want us to find the value of this black dotted line. Okay, they're giving us that the distance from here to here is 15, and these would be radii coming out to a tangent, so these would give us 90-degree angles. Okay, now this shape doesn't necessarily give us anything else to work with, but the trick of the problem comes in the fact that this distance between these two radii is 15 not only here, but it's 15 no matter where it goes along those two lines. As long as it stays between those two radii, they stay the same. So if I were to move that 15 down and create a right triangle, because this would still be 90 degrees, I didn't change the orientation of it, this creates a 90-degree triangle. Now, this obviously goes to 0. This is no longer 7. It moved down 3 units. So since it moved down 3 units, this value is now 7 minus 3, which would be 4. This is still 15, so we would do 15 squared plus 4 squared equals x squared. X is still our hypotenuse. It's the one that sits across from the right angle. A lot of kids want to say 15 is the hypotenuse, but it's x because that's the one that's across from the right angle. So we do 15 squared plus 4 squared. That gives us 241. And then to get our x alone, we have to take the square root of 241, which gives us 15.5. So the distance between the centers of our pulleys would be 15.5. Those are the types of problems you're going to see in today's lesson. Ones where because it's a radius and a tangent, you've got 90-degree angles, which gives us right triangles to work with. Or just the fact that when you draw a tangent out to different sides of a circle, those distances have to be equal. That is the end of the lesson. The homework for each of the classes is as follows.